YouTube, what's up? My name is Miss V and I am a math teacher and I'm about to show you guys some geometry. So if you're trying to figure out how to carry a figure or a polygon onto itself, you're in the right place because today we're going to be discussing how to do exactly that, okay? So when we talk about carrying a figure onto itself, what that basically means is, can I do some kind of rigid transformation like a reflection or a translation or a rotation to this figure and make it look exactly the same? Okay, so usually the two transformations that we mostly do to do this are reflections and rotations, because once you translate a figure, remember translating is a slide, so if you slide it, you're obviously moving it, so it's not going to look exactly the same. Okay, even if you say I'm going to go 4 to the right, 4 down, 4 to the left, 4 up, it's not possible to go right and left and then up and down at the same time. So you got to pick one or the other. So today, like I said, we're going to discuss how to carry a figure onto itself. And as y'all know, or as you don't know, I write on my iPad while I record these videos. So if you, not onto myself, onto itself. So if you see me writing or looking down during this video, is because I'm writing down something on my iPad, okay? So like I said, today we're going to study how to carry a figure onto itself. And usually the two transformations that we use are reflections and rotations, okay? So reflections and rotations. Now, figures that you can carry onto themselves are things like quadrilaterals. So quadrilateral, from the word quad, it's a four-sided shape, okay? So four-sided shape like a square or a rectangle. So a square or a rectangle or a trapezoid, that's also a pretty good one. A kite or a rhombus. What else is another four-sided shape? Other four-sided shapes, I think those are the main ones, but your kite slash diamond is kind of the same shape. And you can also do this with more than four-sided shapes. So like an octagon, which has 8 sides, a hexagon, which has 6 sides. You can also do it with a pentagon that has 5 sides. We're just going to talk about four-sided shapes for right now. So usually with squares are pretty nice because you can reflect them about almost any line that goes through the shape. So for example, I can reflect the square about this vertical line that's going right through the middle of the square. Notice it's cutting it into 2 equal pieces. As long as it's cutting that square into 2 equal pieces, then if you reflect it about that line, then it should map the figure onto itself, or it should make the square literally land directly on itself, okay? So that vertical line works. The horizontal one that I drew there works. The diagonals of a square also work. So a square has what we like to call 4 lines of reflection, or basically 4 lines of symmetry, which is 4 ways that you can reflect that square to make it basically land on top of itself or map onto itself, okay? Rectangles have the same up and down line. Let me pick a lighter color. That same vertical line, rectangles have that. They also have the same horizontal line. As long as it's splitting the rectangle in half, it should work. Now, the diagonals of a rectangle, it's a different story. If you try to reflect it about the diagonal or the line that goes across like this, it may or may not work. It kind of depends on what case it is. If it's a rectangle, like the one I drew here, where one of the sides is longer than the other, then it doesn't work. But if it's a rectangle, because you guys know that squares and rectangles are in the same family. So a square is always a rectangle, but a rectangle is not always a square. Okay, so a square is a rectangle because the definition of a rectangle is that it has 4 right angles. So 4 right angles inside of it. And the opposite sides are equal. So that's the same thing for a square. The only difference between a square and a rectangle is that all 4 sides of the square are equal. Okay. If we do a trapezoid, the line going straight down the middle of that trapezoid that splits it exactly in half, that is usually the only line of symmetry. And then if we do a kite, like the one I have over here, or a rhombus, Line going straight down the middle works. Line going straight across works. If you do the quote unquote, they're not going to be diagonals, but these lines here, those don't work, okay? So this is for reflection. So these are the different reflections that'll map the figure onto itself. Now, with rotations, 180-degree rotations or 360-degree rotations are usually the way to go, okay? For a square, you can either go 180 degrees or 360, it works. For a rectangle, same thing, 180 or 360. For a trapezoid, only 360 works. You have to go in a full circle to get it back to where it was. If you go 180, then it's kind of going to be like this. It's going to look like this instead. Okay. So the longest side is going to be at the top now, shortest side is going to be at the bottom. So that doesn't work. And then for a kite, 180, 360, kite, rhombus, this guy right here, this is a rhombus. That works, okay? One thing I would definitely suggest is that you guys go ahead and log on to GeoGebra or create an account with GeoGebra. It's a free software. It's a great software and I use it all the time with my students. By the way, I'm not being sponsored by GeoGebra to say this. I'm just telling you guys because it's awesome. And you can literally look up an activity called Map Onto Itself. And it'll show you the different ways that you can map a figure onto itself and you can play around with it. Usually with these kinds of activities, it's a lot better when you guys just try it out yourselves. And then from there, you kind of get a better understanding of it because it's very difficult for me to visually show you like, hey, if I grab this triangle or this square and I flip it, look at what happens. It looks exactly the same because I can't physically flip anything on my actual iPad, okay? And by the way, also a triangle has a vertical line of reflection, okay? All right, so this is on figures, how to map a figure onto itself. And like I said, guys, go ahead and log on to GeoGebra also, and just look up the different ways that you can make a figure look like itself and try it out on GeoGebra. That's probably one of the best ways to do this. But I hope you guys enjoyed this video. If you did, go ahead and subscribe to my channel. Give me a like, a thumbs up, and I will see you all in my next video. Have an awesome one.